10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Hi everyone, welcome to our asynchronous class. I prepared this video lesson for you to learn how to name and write compounds using covalent and ionic bond. Kindly join me until the end. Hope you will learn this lesson. So let's get started. In writing and naming ionic formulas, we will depend on the charges. So take note of that. If we will recall our previous discussion, ionic bond is a bond or if they are bonded due to their opposite charges. So we need charges, the positive and the negative charge. Okay. Now, so let's start our discussion. So, writing and naming ionic formulas. So, I have here a blank periodic table of elements. So, as you can see, there are numbers above. So, numbers written above shows the charges. Okay, so let's say for example, sodium or Na. So since Na rather belongs to group number 1, so all group number 1 has a positive 1 charge. They have the positive 1 charge. For group 2, they have the positive 2 charge. And then the next one for this group, they have the positive 3 charge, followed by the positive 4. And then starting from nitrogen below, they have negative 3 charge. For oxygen group, they have negative 2 charge. And fluorine, they have negative 1 charge. So as you can see, as we go on to the right, the elements become more negative. Okay? Alright. Now, so example is if ever we have lithium and oxygen. So, as you can see, they are not yet bonded. Okay? Now, so in ionic bond, we need charges. Okay, so let's take a look. So let us get the charges of each. So for lithium belongs to group number 1. So again, group number 1, they have a positive 1. Okay, positive 1 charge. So for lithium, so we get the positive 1. So if you cannot see any number, it means it has a 1 charge. Next, for oxygen belongs to this group. So they have a negative 2 charge. So 2 negative. Okay? So lithium positive 1, oxygen negative 2. Okay. Now, so the first thing that you should do is to balance the charges. Okay? Again, the first thing that we should do is to balance the charges. So again, for lithium, it has a positive 1 and for oxygen, it has a negative 2. So let us get the charge and then we will balance the charge. So since lithium, they only have a positive 1 charge and oxygen has a negative 2 charge. So as you can see, lithium is lesser than oxygen. So in order for these elements to be balanced, we should add either way. So we can add from lithium, we can add from oxygen. But since lithium is lesser, so we will add more lithium to balance with oxygen, since oxygen has two charges. So we add here 1 lithium again. So 1 plus 1 is equal to 2. And then, so it balances out with oxygen. So we have 2 lithium here and 1 oxygen. Okay? So if we will write the chemical formula for lithium oxide, so the chemical formula for lithium oxide is Li2O. Li2O stands for lithium oxide. Okay? Why lithium oxide? They are bonded. Okay? That is why it becomes oxide. We change oxygen to oxide because they are already bonded. Now, so here, this is our equation, no? This is our solution. So, we literally count many how many elements are present. So here, we have 2 lithium and 1 oxygen. That is why we get Li2O. Okay? Another example is we have potassium and nitrogen. So again, the first thing that you should do is to balance the charges. So let us get the charges of each. For potassium, okay. For potassium, they have a positive. It is a positive 1 charge. And for nitrogen, it is a negative 3 charge. Okay. So positive 1, negative 3 charge. Okay. The next step is we should balance the charges. So in order for us to balance, we either add from potassium or we add from nitrogen. Okay, so nitrogen has a 3 negative charge and for potassium, it has a positive 1 charge. So since potassium is lesser, we will add more potassium in order for it to be balanced with nitrogen. So we will add how many? We will add 2 more to have 3 charges for potassium. So 1, 2. So 1 plus 1 plus 1 is 3, K3. And how many nitrogen can you see? Okay, we only see 1 nitrogen. So K3N is the chemical formula for potassium nitride. Okay, so again, literally we will count how many elements can you see. So in here, we have 3 potassium and 1 nitrogen. So K3N. That is potassium nitride. Okay. Next. Another example is we have aluminum and oxygen. So again, we will get the charges. So aluminum and oxygen. Aluminum is from this group. So it has a positive 3 charge. And we need oxygen. Oxygen it has a negative 2 charge. So positive 3 and negative 2. Okay. So once that we get the charges, we should balance the charges. So Al3O2. So since oxygen is lesser than aluminum, we will add more oxygen. Okay. So we have here 2 oxygen, so O2 negative and Al3 positive. So we will add another oxygen. So O2, 2 plus 2 is 4. And this is 3. Okay? So, meaning to say, oxygen it has a greater number. So we will add another aluminum. So aluminum 3. So 3 plus 3 is equal to 6. Now, since aluminum has 6 charges already, we will add another 2 from oxygen to get a total of 6 as well. So 6, 6, meaning to say they are already balanced. Okay? we will not change the charge. Okay? We will not change the charge. Okay? Now, so to get, how many aluminum can you see? 1, 2. So Al2, how many oxygen? 1, 2, 3. Al2O3 stands for aluminum oxide. Alright. Next. Ionic formulas, we can also write and name ionic formulas using the transition metals. So take note, when we say transition metals, these are the metals that can be found at the middle of the periodic table. So transition metals are able to make more than one type of ion, and each of these have different charges. So we have here an example. Iron is an example of transition metal. So again, when we say transition metal, they can have more than one type of ion. So it can have a positive 2, positive 3, positive 4, positive 1, and so on. Okay? Meaning to say they have many charges. Why? Because it is a transition metal. Another example, we have gold. Gold can be positive 3, positive 4, and so on. For manganese, same. It can be positive 2, positive 3, positive 4, and so on. Okay. Now, so take note, if ever we will have a transition metal together with an ionic compound, we need to use a Roman numerals. Okay, again, we will be using Roman numerals. Okay, so example is this one. Formulas with transition metals. Example, we have manganese, close open parenthesis, and Roman numeral number 2, chloride. Iron, 3, oxide. Okay, now, so take note again, we will have the same process like what we did a while ago. Same process, we will get the charges first of both elements. And then take note of the Roman numerals. It is used only if we have transition metals in an ionic compound. The Roman numerals refer to the charge number. So, let's say for example, we have a Roman numeral number 2. So, meaning to say, manganese it is a positive 2 charge since we have a Roman numeral number of 2. Same with iron. Iron 3, meaning to say iron has a positive 3 charge. Okay, so again, the Roman numeral refers to the charge of an element. So example, we have chromium 2 iodide. Okay, so as you can see, we have a Roman numeral. Again, why do we have a Roman numeral? Because this is an example of ionic compounds with transition metals. Okay, once that you saw Roman numeral, meaning to say it has a transition metal. So, in this example, chromium 2 iodide, the Roman numeral number 2 refers to chromium. Okay, so meaning to say chromium has a positive 2 charge. Alright. Okay. So Cr2 plus. Okay. Why Cr2 plus? Because we have a Roman numeral of 2 here. Next, we get iodide. So, what is the charge of iodine? Okay. Iodine is negative 1. Alright. So, negative 1. Now, since we have 2 chromiums, so we will add more iodine. Okay? Why we will add on iodine? Because again, the charge of iodine is negative 1. So we will add another iodine to get 2. Okay? So 1 plus 1 is equal to 2. So it is already equal with chromium that has a 2 positive charge. So, since we already balanced the charges, so the answer will be Cri2. Why Cri2? Because again, we'll literally count the elements present on our equation. So we have 1 chromium, okay, Cr, and then we have 2 iodine, so I2. CrI2 is the chemical formula for chromium 2 iodide. This is the chemical name. Okay. Another example is manganese 3 oxide. So manganese, it has a 3 positive charge, and oxygen is a negative 2. It has a negative 2 charge. Okay, so positive 3, negative 2. So we will add more of oxygen. So if we add another oxygen, so we get 4. So meaning to say it has a greater number compared to manganese. So we will add again another manganese, Mn3 plus positive. So this is already 6, this is 4. So we add another oxygen. So 2, 4, 6. So it tells that it is already balanced with manganese. So 6 positive and 6 negative. So let us write the name for manganese 3 oxide. How many manganese can you see? We have 2 manganese, 1, 2. So Mn2. For oxygen, we have 1, 2, 3. So O3. Mn2O3 is the chemical formula for manganese 3 oxide. Okay. Another example is, okay, transition metal with polyatomic ions. So when we say polyatomic ions, these are the ions that cannot be found using the periodic table. So I have here examples of polyatomic ions. We have ammonium, carbonate, hydroxide, nitrate, nitrite, phosphate, sulfate, and sulfite. So these are the examples of polyatomic ions. Again, when we say polyatomic ions, we cannot see these examples using the periodic table of elements. So example, we have lead 4 nitrate. So lead, we have Pb, okay, so it has a positive 4 charge, Pb4. So Pb4 plus, and then we have the nitrate. So nitrate is an example of a polyatomic ions. Okay, so what is the symbol for nitrate? So let us see. Okay, so this is nitrate. So nitrate is NO3 negative. So meaning to say it has a negative 1 charge. So NO3 negative. Now, so once that we already know the charges, we will now balance it. So we have PB4 plus and NO3 negative. Okay. Since we have a lesser number of nitrate, so we will add more nitrate on this. So again, it has a negative 1 charge. So we add, since lead has 4 charges, positive 4 charges, so we add more nitrate. So nitrate, nitrate, nitrate. So 1, 2, 3, 4. So it balances with lead. Okay. So let us write the name. So literally, we count the elements present. So we have 1 lead here, so Pb. Okay, and then we will use close open parenthesis. Excuse me. Why we will use close open parenthesis? Because this is a polyatomic. Again, we will only use close open parenthesis if it is a polyatomic ion. So, close open parenthesis, NO3. How many nitrate can you see? 1, 2, 3, 4. That is why we have a subscript of 4 here. That shows that we have 4 nitrate on this solution. So, PbNO3 4 is the chemical formula for lead nitrate. Okay? In writing ionic formulas, you can also do the cross. Okay, so as you will notice, you do crossing as well. Okay, I only discuss with you the step by step in order for you to really understand how to write and name ionic compounds. Okay. Another way to write ionic compounds is it is combined with a polyatomic ion. So, a while ago, I have mentioned that when we say polyatomic ions, these are the ions that we cannot see using the periodic table of elements. So, we have here an example of polyatomic ions. Okay. So, let's say, for example, we have calcium 2 positive and NO3 negative. Okay. So, we have calcium and we have NO3. What is NO3? So, this is a polyatomic ions. NO3 stands for nitrate. Okay. Now, so since we have 2 positive, so meaning to say, that is the charge of calcium. So, Ca2 plus NO3 negative 1. So, we will add more nitrate to balance with calcium. So, 1, 2. So, it balances with calcium. So, we have 2 positive and 2 negative. Now, so let us write the chemical formula for calcium nitrate. How many calcium can you see? We have only one calcium, so Ca. Close open parenthesis. Why close open parenthesis? Because this is a polyatomic ion. So NO3, how many NO3 can you see? We have 2, 1, 2. That is why we have a subscript of 2. Okay, so this is the chemical formula for calcium nitrate. Okay. Next, another example is we have ammonium nitride. So ammonium is a polyatomic. So let us get the symbol for ammonium. So we have NH4 plus, and then we have nitride or nitrogen. So what is the charge for nitrogen? The charge for nitrogen is -3. This one. Okay. So let's go back. Okay, so N3 negative. Okay, so since we have lesser NH4 or ammonium, we will add more ammonium to balance it with nitrogen, which has a 3 negative charge. Okay, so we add 2 more. So NH4, NH4, 1, 2, 3. So it balances with, this is already 3 positive and 3 negative. So they are already balanced. Now let us write the chemical formula for ammonium nitride. How many ammonium can you see? 1, 2, 3. So NH4 close open parenthesis. Why close open parenthesis? Because NH4 is a polyatomic ion. Okay? NH4. So how many NH4? 3. Okay. Now, how many nitrogen can you see? 1. So NH4 3N is the chemical formula for ammonium nitride. Okay. Let us now proceed on how to write and name covalent bonds. So to write formula and name compounds, we have the following rule. Okay. So for rule number 1, for the first element, start with the element name. For rule number 2, for the second element, start with the IDE name. So the second element will end with IDE. Okay? And the third rule, use prefixes to show how many atoms of each type are there. So prefixes, these are the words that is written before the element. Okay, so what are those prefixes? So we have here this one. So we have the numbers 1, 2, 10. For number 1, we will use the prefix mono. For number 2, we will use the prefix di. For number 3, we will use the prefix tri. For number 4, we will use the prefix teta. Number 5 is penta. Number 6, hexa. Number 7, hepta. Number 8, octa. Number 9, nona. And number 10, deca. So another rule that we should remember is do not use mono on the first element. So we should always remember that. We will not use mono on the first element. Next, if you have AO or OO, turn it into O. So later on, I will give examples of it. So let's say for example, this one. So again, if you have AO or OO, turn it into O. So what is that? So let's say for example, we have mono, okay? Mono, monoxide. Dioxide, trioxide. So instead of tetraoxide, we will use tetroxide. Instead of pentaoxide, we will use pentoxide. So we will follow this rule. Instead of AO or OO, we will turn it into O. So instead of pentaoxide, we will use pentoxide and so on. Okay, so remember this rule as well. Okay, next. Example, so we are now already with covalent bonds. Example, we have N2O3. So what are the numbers below? The numbers below are known as the subscripts. So we will follow the rules. So for nitrogen, since there are two nitrogen, so N2, no? We have two nitrogen. Since there are two nitrogen, we will use the prefix di. Okay, so again, we will follow the rules that I have mentioned earlier. So we have two nitrogen here, so we will use the prefix di. So it will be now called dinitrogen. Okay, next for oxygen, since there are three, we will use tri. So oxygen will be named as trioxide. Now take note, since it is the second element, instead of trioxygen, we will follow rule number 2. It should end with IDE or oxide. Okay, we will not use oxygen since they are already bonded. We will only use chlorine, fluorine, and other elements if they are not yet bonded. But since we are talking about bonding, since we're talking about ionic end compounds, we will use IDE at the end of the second element. So the name for N2O3 is dinitrogen trioxide. Another example, we have P4S10. So again, the numbers below are the subscript. So the name of this compound is tetraphosphorus decasulfide, white tetraphosphorus decasulfide. So we have 4 phosphorus here, so we will use tetra. So tetraphosphorus. Next, the second element is sulfur. So we will use since it has a subscript of 10, so we will use deca. So instead of decaoxide, we will use decasulfide rather. Okay? Since this is sulfur, so decasulfide. So again, we will use IDE because this is a covalent bond. So the second element will end. They will use the suffix IDE. Okay. Next, example number 6, note number 6, we have CF4. So this is carbon tetrafluoride. So as you can see, we did not use prefix on the first element because it is, we have the rule on the first element. We will not use mono. We will not use any prefix. We will not use mono since we have only one carbon here rather. Okay, again, we will follow, on this example, we follow the rule wherein we will not use mono on the first element. But if it has a C2, so we will use the prefix di. If it has a C3, we will use the prefix tri. Okay? So we will not use mono on the first element. That is the rule. Okay? So I hope that is clear to everyone. Next, note number 7. We have Cl2O7. So this is dichlorine heptoxide. So again, instead of heptaoxide, okay, we will change it to heptoxide. Okay. So that is the end of our discussion. I hope everyone learned something for today. Goodbye.